Okay, so here we're looking at NBA heights. So the number of NBA basketball players who are taller than a given height can be modeled as pH equals 485.896 over the 1 plus 0.007 e to the 0.462h players. And height is line input so that h of x is equal to x minus 68, where x is inches in height and data is from 68 to 88 inches. Okay, now we're supposed to write a model for the number of players as a function of height, and then write a model for the rate of change of the number of players with respect to height, and then calculate the number of players and the rate of change of the number of players who are 6 feet tall, then write sentences of interpretation for the number of players and the rate of change. So first, 6 feet tall, that's going to give us x equals 72 inches. Because we're in inches, we have to make sure we're using inches here, not feet. So for part A, if we're supposed to write a model for the number of players as a function of height, all right, so P is the number of players. So we're going to have P of H of X. Okay, so that's what we're going to do. We're going to plug in H of X in for the H up here. Okay, so that gives us then 485.896 over 1 plus 0.007 e to the 0.462h, and that was supposed to be x minus h, sorry, or x minus times x minus 68. Okay, there we go. And that's players. All right, so that's what we would get if we were doing this as far as the just that first function, okay? And so then after that, what are we going to do? Well, then after that, we have to actually do some work because we're going to go to doing the derivative of this. And so I think probably what we need to think about is, so I think the first one we can do easily. So for part B, we'll need the h of x is equal to x minus 68. So h prime of x is equal just to 1. So that one, that's easy. But the rest of them, we're going to have to work with this kind of function up here and take the derivatives and stuff. So what I'm going to suggest to doing is, let's say, I guess we can say, oh, b's already over there. So let's let our u of h equal the denominator up here, just what we have here, okay? And so then we have 1 plus 0.007 e to the 0.462h. And then we can rewrite our p of h as, our p of u rather. You have to make sure you keep your letters in line or you're going to have everything messed up because we're going to plug this into here. And so that was the 485.896. And then we say u to the negative 1. So we'll just bring it up to the top and call it negative 1. Okay. Now, can we take the derivative of both of those? Yeah, we can do that. So u prime of h is equal to, well, we take the derivative of that, that's going to be 0.007. Now we think of that as a number, and so we'll take then the ln of e to the 0.462, and then we have still e to the 0.462h. So that's kind of like your b, and then your b to the x or h or whatever. Okay, so that would be the derivative of this. Now the derivative of p is going to be, well, now we bring the negative 1 down, negative 485.896 u to the negative 2. Okay. So now we've got those. Now what do we want when we get done? We want the derivative, and it's going to be the derivative of p dp dx, basically. We want the dp over the last thing, which is x. And so let's try to figure out if we can get there from what we have. So dp dx. Well, first we'll do dp, and we know dp du. And then we can go du dh. And then we know, where did we write that? Over here, dh dx. So then we can go dh dx, and that cancels, and we end up with dp over dx, which is what we want. So then when we get done with this, then we just have to make sure all of our variables in the final thing are x's and not any h's or anything else. So let's write this. So dp du, that would be this. So we'll have a minus 485.896. And see, I already see a u here. So I'm going to convert this before we do anything to this. And so that's going to be a 1 plus 0.007 e to the 0.462 h. And that whole thing's to the negative 2. Okay, so that is my dp du. Then I'm going to multiply that times, now I need du dh, so I'm going to do this one. So that's going to be 0.007 ln e to the 0.462 e to the 0.462 h. And that's all I have there. And then dh dx, so that was the we had over here, which is just equal to 1. Okay. Now, remember I said we have to have the variables of x, and we've got an h and we have an h. So what we need to do now is put those h's back as the value x minus 68. So now we get dp dx equals negative 485.896 times 1 plus 0.007 e to the 0.462 x minus 68, and then that's to the negative 2 times 0.007. And I've noticed something here. This is ln of e to something, which means we could bring that down in front, but I'm just going to keep leaving it as of what we have here. But this actually is just going to be the 4.462 if you actually work it out. But we're just going to leave it that way just for sameness sake, and we don't change anything. And then it's u to the 0.462 x minus 68 and then times 1, but it's gone. Okay, so now we have dp dx. Everything is x's or numbers, so that looks good. So I believe that would be B. And now for C, we need to calculate the number of players and the rate of change of the number of players who are 6 feet tall. So we need to plug in 72 for this. So we'll take and do our plugging in our value of 72. And then after that, we have to go in and plug in 72 in this equation. So maybe while we have this one here, let's do dp dx, and x equals 72. So it's a negative 485.896 times 1 plus 0.007 e to the 0.462 times x minus 68, and to the negative, oh, that was 72, not x now. And it's to the negative 2, and 0.007 ln of e to the 0.462 e to the 0.462 times 72 minus 68, and there. And so now let's go put that into our calculator. So let's go over here. And so now what we need to do is we need to plug that in, and when we do that, we'll have a long thing to type. So we'll have negative 485.896 times 1 plus 0.007 e to the 0.462 times 72 minus 68, parenthesis, arrow down, parenthesis, and that's 2, the negative 2, arrow down again, and then it's times, and we have 0.007, and we have ln of e to the 0.462, and then arrow down and parenthesis, and then we have e to the 0.462 times, and then we have 72 minus 68, parenthesis, arrow down, and in theory array. That should give us our value. And so negative 9.143. And we forgot to put our units here. So what were our units? So it's going to be number of players. How many players per inch, because our x is in inches. And that gave us then negative 9.143 players per inch. Okay. And so now what we need to do then is we need to go back and plug in the 72 into our other equation. And so when we do that, that's going to basically get rid of everything but that one part. And so when we do that, let's go over here again. Well, let's make sure we have the right equation we're going to plug it into. Let me just type it in my calculator here. 45.896 divided by 1 plus 0.007, and then e to the 0.462. Yeah, so that's what I got. So I'll type it here anyway. But what we're just going to do is we're just going to basically have uh, this here part here. We're going to have the 485.896 divided by the 1 plus 0.007, then e to the 0.462, and then times 4, because I just did that in my head, and then down, and then parenthesis, and that should give us 465.226. And so let's go ahead and do the next page then. That was the P of, let's write all of it, P of H of X, P of H of 72 is equal to, and then that was going to be 465.226, and so that's roughly 465 players. Okay, so that would be that part. So we got the players, we've got the players per inch, and we've got our, of course, our function here, our dpdx, that we have our players per inch that we had to plug it into, and then we got our a part here too. So we have everything there, and so then the only thing left is to write a sentence basically of interpretation for the players and the players per inch. And so it's going to be, what does it say, year and it doesn't exactly say the year, so I'm going to say uh, the number of NBA players who were, now remember, this is going to be who are going to be taller basically than that 68 inches, who were taller than 68 inches, or 72 inches, sorry. It's 72 minus the 68. So the difference is kind of what I'm thinking here. So they were taller than the 72 inches was, and that was this number here, 465 players. And what did we get for the rate of change? The rate of change was negative 9.143 and was decreasing by 9.143 players per inch. And we probably should say of height, that was kind of given, but we'll say of height so we know for sure. So the number of NBA players who were taller than 72 inches was 465 players, and it was decreasing by the negative 9.143 players per inch, or it was just decreasing by that. So we put the decreasing as the negative. Okay. All right. So let's stop there and we'll come back with this one.